you please tell me that, what is the requirement now? What we want to do now? Jale, yeah.
Uh, so first thing is, take a substrate, quartz substrate, having thickness around 500 micron.
Okay. So what you want to create a FSS unit cell, right? Correct?
Yes, sir. Yes, sir.
Okay. Okay.
Sir,
Mm,
sir, here one question in my mind.
yeah.
So here are the three options. Please go to next.
Okay.
Here the three things here. The
Yeah.
first dashboard shows the metamaterial unit cell and FSS full structure and metamaterial full structure. So why should we go to the unit cell structure? So
The
if
thing
we choose
is,
the full structure,
yeah, actually, the thing is, see, your unit cell, now currently you are going to simulate only unit cell, right? It will
yeah.
select the Floquet boundary and also the, see, you can even you can create your own template also. Doesn't matter. It is already predefined. So in this unit cell, no, what you will have is like, for example, Floquet port or a corresponding boundary condition will be already defined. If it is full structure, no, the corresponding boundary condition will be defined. For example, time domain solver with the boundary as open space like that. So the only thing that is the one. Nothing else is
Okay,
actually there.
okay,
Yeah.
okay, okay. Okay. Please go ahead.
Yeah. Then you
And
can
then
just
another question that here are the three options: cage reflection,
yeah,
dispersion
yeah.
diagram.
Oh,
With
okay. This is
so
the
how is the
latest
debate?
version. Latest version, right? Okay. Maybe the thing is, see, if you want to see the band gaps in the under dispersion diagram, the operating frequency range, I think maybe this I never seen, and then just now I am seeing this actually dispersion diagram, rectangle lattice, hexagonal lattice, like that. But usually we select this one, so phase reflection diagram. So our
Okay,
reflection phase, no, our interest is this. For example, if you are simulating any band gap structures or metamaterial like that, you can go for this option. I believe so. I have never seen this. Now they included this one. I think so. Okay.
okay, sir. So you can teach me the all the things. So
Yeah,
I am
yeah.
the basic learner. So yeah.
No problem. The frequency domain and time domain. So the thing is, for normal, see, time domain, no, it will not work with the Floquet port basically. Okay. It will only work, frequency domain only work with this Floquet port. So that's why we are
So
selecting.
what is Floquet port?
Floquet port, actually, the
What?
thing is, just let me draw this. I don't know.
Just go ahead and next, and then you can structure. Just make the structure, and then you can
Yeah, yeah,
define the
yeah.
detail.
That's what.
Okay, sir.
Where is that?
Next, no,
Yeah,
next.
yeah, yeah. I get. I see. The thing is, see, Floquet port, right? 1 minute. I will just show you this unit cell, right? Okay.
Okay.
What you were asking? Floquet port, right? Actually,
Uh,
what do you mean by Floquet
yes,
port?
sir.
Correct, correct. Okay.
Yeah, yes, yes, sir.
Uh, the thing is, see, you have unit cell like this. Okay. Okay.
Mm.
Then, for example, you will create a boundary like this. Then you have a planar waves. Then it is getting incident on this. So then
Mm.
you will simulate, right? But in practical scenario, it is the unit cell not going to be individual one, right? You will have
Mm.
a this unit cell like this, right? It's a periodic structure, right? Maybe
Yes, sir.
in
Okay.
principle. Okay. So if you want to analyze this behavior, for example, this unit cell behavior in presence of these unit cells, so what it will assume is it will assume infinite number of unit cell, periodic, the same structure is repeating infinitely. That is how it will assume, and then it will evaluate this performance of this unit cell basically. Okay.
Okay. Okay.
That's why, so it consider, approximately the mutual coupling between the unit cells. That's it. Okay.
Okay. Okay. Okay.
The
Okay.
other
Okay.
method is like, for example, you can use a TEM waveguide. So TEM means
T.
what? TEM waveguide. Okay. So usually,
Uh,
no, waveguide, no, will have a TE mode like this. Correct?
uh,
TE mode waveguide. Okay. TE10 mode
uh,
waveguide. But see, if you
okay.
want to have, for example, both the E field and H field and orthogonal to each other like this, TEM waves. So we cannot make this one. So one wall will be electric wall, other wall will be magnetic wall. So that's how we can make TEM waves. So if you are simulating, for example, see, you can simulate a waveguide like this. So one wall you can consider it as a magnetic wall, Another wall, you can consider it as an electric wall. So you will generate the TEM waveguide, which is actually a planar wave only. Okay, TEM waves. So transverse electromagnetic waves. So this is the like a front view. If you look at the the waveguide like this, so you can see here, it will be something like this.
Okay.
So here you will see the, you will have the unit cell basically. Okay. So here the plane waves are there. Okay. It is a TEM waveguide where you will define this as a electric plane, a tangential E equal to 0. This you model it as a tangential M equal to 0, H is equal to 0, or we can say magnetic wall. This is electric wall. So your plane wave is just incidenting that and comes back. But here actually we will only simulate as a single unit cell basically. Okay. We are not considering any adjacent unit cell. Okay. That's why
Okay,
we
okay.
are going for this
That
one.
means
Yes.
result also should be different
Yeah, yeah,
from
no,
the
no, not
Floquet
that
code
different.
what.
Not that different. See, the thing is, see, here, no, we are assuming only same unit cell, right? Mutual coupling, maybe like, kind of a small change will be there, but not, for example, in phase, if you see 5 or 6 degree, 10 degree, like that, the difference will be there at each frequency. Other than that, no problem. Okay, actually. So,
Okay, okay.
but, it is better to go with this approach only. That's it. Okay. That's
With the Floquet mode approach.
Yes, yes, yes.
Okay, okay, okay. So please go ahead.
Yeah. So then you can go to next. Here you can just see, okay, you want to make it as a terahertz one, correct?
Oh, yes, sir. Yes, 1 to 3 terahertz. That means the
Yeah, yeah, yeah.
dimension also
Terahertz.
requires micro.
Yes, yes,
Mm.
yes, yes. Okay. Then
Because
you can
one
mention.
to 1 to 3 terahertz. One 0.2, 0.2 to 3 terahertz. Mm. 3 terahertz. 3 terahertz.
You can if you want to see the fields, but you won't get matching anything. You just to see that, and then you can see transmittance, reflectance, absorbance. So it's earlier, no, we used to capture the S11 and then calculate these values. Usually it will be calculated by manually, but now it is also giving that value already. Okay.
Okay, sir.
So now what do you want to do now?
Now make a structure. Take a substrate, quartz substrate having thickness 500 microns.
Okay. So the thing is, you just create escape, and then you will
Sir,
see.
please remove this one. The zoom dashboard is showing in this particular.
No, 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 no. I don't see anything.
Just wait a minute.
You can just go down or close it. No problem.
So how to close?
Maybe I just is it clear now? No? Can I
Mhm.
start? So you can
Yes, sir.
click on this one. You can click on this one. Then press escape. You will see the substrate. Okay. Then you were telling right. So what is the value you want to put?
So suppose I am normally taking minus px by 2 and minus px to plus px. So I can, if I want to uh, parameter shift, and then we can change
Yeah, like
px
this.
by,
Okay.
okay, yes, sir.
So
Ey by 2.
yeah, yeah. Then this is the width of the red, length and width. The thickness may be
Uh,
how much you
uh,
want?
so how much approximate for quartz substrate? 500 micron.
500 micron. Okay. So which
Uh,
means uh,
uh,
0.5 mm,
so
right?
0.5 mm. So
Yeah.
already we defined the micron. Already we defined it in the
Yeah, yeah.
dimension.
Yeah, yeah. TH. Let's say TH. Okay. Thickness.
Okay.
You can define the substrate, load material. Then
Yes,
here
sir.
you can just, select the material. Which material you want?
Quartz. Quartz, no, using material.
Lossy. Yes, yes. Then you can just preview. You enter the value. What is the value you want? 550?
Huh. 550. It should be dimension 2 inch by 2 inch. That means that
2 inch by 2 inch. Oh, that much big.
so actually we buy some wafers, sapphire wafer and the quartz wafer.
But
Uh,
no, the thing is, unit cell no will be of lambda by 2 usually. Okay, lambda by 2 of
so
that frequency.
so अच्छा तो 150 ना
150 micrometer.
हाँ माइक्रोमीटर
Okay,
because 1 terahertz equivalent 300 micron and
okay,
then
okay. You can give description like this. For example, length of the unit cell like that. Okay, then you can just
so, so you told no unit cell parameters should be lambda by 2 no
yes, 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 yes.
so it's a higher frequency range and lower frequency range
Basically,
which
you can
which
take a mid frequency, okay, or else high frequency. Okay, both you can take. Mid frequency should
okay
be good actually because you can cover both the region.
then it should be
Ah, okay, okay. For
it,
now,
uh,
just I'm just putting these values, just
okay
values. Okay.
okay
So thickness, how much it will be?
500 micron
Oh, 500. So greater than that width and this one.
huh so actually that's the reality na so actually in a thick so we cannot for terahertz thick sample should be the better
Yes,
for
yes.
measuring the voltage.
You
So
just
it looks like cylinder.
yes, yes, yes. That's a
That is the problem,
yes,
and
yes,
it is
yeah,
a new domain actually.
yes,
So
yes. So now you can go to boundary. Then you can see here that that you can see here that Floquet boundary. The here actually you can
so
put this.
so one more question: when you are defining the Floquet boundary, so
Okay,
how you choose that this type of particular thing? Suppose phase, theta, and all about this.
you're telling about this or what?
नहीं, I'm talking about the Floquet boundary. You click the yeah, then
Yeah, yeah,
the Z mean port and
yeah.
how
Ha,
to
ha,
define
ha.
the Z mean.
This
Uh,
one, no. See, the thing is, see here. Actually, if you are defining two ports in general, no, you can see here. I just cancel it. See, the thing is, you can see here by default, no, it will take two ports basically. Okay. So, let me. So you can see here. This is Z max. Okay.
mm,
This port, actually, port number one is Z max in that definition. Port number port number two is Z min. Okay.
so here the init one two is not defining no?
Sorry.
how uh, uh, how to see that this is port one and this is port two.
Okay, 1 minute. You can see here where it is showing.
Okay,
This
okay.
this is port 2. Okay.
That's
Okay.
a port two. Z mean that's a Z mean. You said okay.
Okay. Then now then boundaries. So you can see here Z min and Z max. You can just define. Okay. Here actually two ports means okay. I think just now I uploaded the video, another video. Why it is two? Because the thing is, see, let me go to this control. So the thing is, if you are having dual polarized one, you have to see this one and this mode, right? TE mode and TM mode. So in
Mm,
order to check this is a dual polarized or not, that's for that only we are just using this two mode. Okay. Okay.
okay, okay.
Now then you can go to this one. Here actually distance to reference plane is see nothing but I will go to here. See this is the port we are exciting. Uh, this is the reference plane basically. See reference plane is I can keep anywhere that I want. Okay, but usually we keep it at just above the unit cell basically. So just
So what is the importance of the reference? Means
the
if we
thing
don't put the
is
reference,
the thing is how it measure is. Let me draw this one. So for example, this is the unit cell. Okay, This
Hmm.
is the port you are exciting. This is the initial. Okay. So what I am doing is, see, I'm just sending the signal and this gets reflected. So if I measure just above this, okay, I can
Hmm.
get actual, the reflected signal, right? If I'm getting in between here or something like that, it may interfere with the whatever signal is going here. Correct? That's why we are using this distance as a reference plane, distance to
So,
reference.
putting reference plane is mandatory or it is optional?
No, no, no. I think it's better to put actually. Yeah. Because each if it is a complex unit cell, no, you will get a different behaviors usually. But normal structure, you will not to have much impact, but better to put that one. So this one, no, you can just see initially, no, this distance, no, it will automatically taken as lambda by 4. Okay.
Automatically taken level one, no?
Yes, yes.
That's
So now you have to, move this reference plane. Reference plane is actually sitting here, basically. You have to move that reference plane to lambda by 4, right? That's why we are putting minus lambda by 4, basically. Minus lambda by 4
okay.
is, what is that? 75, correct?
75. Yeah.
Okay. Then here you can put, like, for example, 1 terahertz or, center frequency. Automatically this get updated.
What is the short evolution point?
What is that?
Uh, 1 terahertz means the short evolution point.
No,
Yeah.
no, I'm saying about center frequency. I'm saying.
Okay, 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 okay.
Okay. Then you click OK. Then click OK. Okay. I think, for further information, you can just I just uploaded one video. You can just see, what are all
Okay,
information
sir.
are there. Okay. Now, if you look at this, you can see here. So you can see here. See, just so
It is good.
zoom. I will zoom and show you.
Okay.
Oh, sorry. You can see here.
Yes, sir.
Yeah, you can
Uh,
see here. This is the port. It's just
but uh,
sitting.
but 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 this is inside the
Yeah, yeah, yeah. Why it is? Because the thing is, it is actually, it is not just half between that, all right? Because, this thickness is high. So what I will do, I will just, not this one, not this one. Okay. Uh,
okay. You have to change the thickness.
yes, no, no, no. Minus TH by 2 to TH by 2.
Hmm.
Let me check this one now. Still, what is the offset?
Sir, actually, we are taking the center frequency one, but the center frequency is not the one
Ah,
because the
okay,
we
okay, 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 okay. Correct, 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 correct.
because we are taking the one 0.2 to 3 terahertz. That means the
Okay.
as the
Okay,
interval
okay.
is
What I will do, see, what we can do is, see, the thing is, if you are
uh,
changing the frequency, you can go to background, and then here actually
center
you can mention
so
like
center
this.
frequency should be the 1.4. Center
Okay,
frequency
okay, okay.
no, sorry, or 1.6.
Okay,
Sorry,
now I think
1.6.
it will come like this. Can you see here? Oh my God. 1.6, huh? Okay. Sorry, it's not coming. So you can make it as 0. Just I will just yeah, if you adjust that frequency, you will get it that automatically. Okay. Actually, this will be calculated by with the help of center frequency.
One,
Yeah. I think, maybe you can just correct that, no problem. Okay. If you put correct
okay,
frequency, whichever dimension, it will automatically take it. Yeah.
okay,
So
okay,
anything
okay. That's
anything
good.
else you want to discuss?
No, no, no. Just go ahead, sir. Go
Yeah.
ahead.
That's all. Actually, you can just start simulating this, and then you can see the results. I think some of the videos you might be. I think there is one video called "How to Simulate Dual Polarized Unit Cell." You can see that. After that, the steps are follows. Okay, what are all results you can see? All that stuff I just explained. Okay, yeah, you can go through that, and then if you get any doubts, no specific doubts, please let me know.
On it, and the suppose setup somewhat. Okay.
Hmm.
So, my older senior, what I'm saying he's now becoming a professor, but I don't have any contact with him.
Okay.
But once upon a time, when he told me that you should take the all plus Phuket short type. Okay,
Yeah, then
and
you will get all the modes, right? That's it, actually.
so all the words. What is the difference in least, Z-min, Z-max, and all plus Phuket? So, some basic questions.
The thing is, see, here, no, I have maybe see by default it is taking either Zmax or Zmin, right? But
Mm,
if you want to excite both the ports, you can see all the results. For example, S21, S22, S11, like that. So one means max, and two means min. You just manipulate means map that information. You will get all the related information, cross polarization, co-polarization, everything you will get it. That's why I think he has told that, right?
okay, and then second thing is that
Yeah, this one
he
it will
told me
take
the
longer.
uh,
Yeah. Huh.
first calculate port mode only, and then
Ah,
if you have get some
yes,
success, then go to the
yes,
adaptive petrahedral mesh refinement. So
exactly.
what is the basic difference?
Actually, the thing is,
So
first you are just, exciting the port modes and then getting the results, right? Preliminary results. Then you
okay,
want to refine that. See, the meshing, no, initially it will take a rough meshing. Okay, meshing, right? How
mm,
meshing works. I will just give you high level thing. This is the structure, right? How this tool works is, for example, it will just, for example, it will just mesh like this, like this. Okay,
mm,
then what? That's what we always study del lizard like that, del A, del B like that, right? Okay. Usually,
okay,
we you always study like this, right? Del JS, del JB, del E like that. In Balani's book, you might have studied, right? This always we talk about del. That del is about this one. Okay. For example, this one, no, how the tool works is. See, the thing is, it is actually impinging some waves, right? Okay. And then here actually there is a current density will be there, right? In this particular portion, small portion, there will be a current density. Okay. There will be a current density. So based on current density, according to Ampere's law, what we can find out? We can find out H from Js,
mm,
right? Then
mm, mm,
from Faraday's law, I can able to find out change in H will lead to change in E. I can find out E.
mm,
Then I can just calculate. So I will just calculate for this particular mesh. Then I will integrate all the values, just a summation basically. So I will calculate for the portion, all the portion. Then I can just integrate. So the integration means some summation with respect to limits. For example, minus infinity to plus infinity or minus t to plus t. The what is the boundary you are giving? So according to the boundary condition, it will just calculate and then it'll give you the results. So the adaptive means what it does is see first. See the thing is you will also see I think specials or somewhere. Mm, yeah, here accuracy you can see. Can you see here accuracy?
mm, mm,
So this accuracy is nothing but 1 e power minus 4 means 10 power minus 4. Okay. So 10 power means, see the thing is 10 power minus 4 means, um, 10 power minus 4 means is actually 1 by 10 power 4, right? Okay. If
mm,
you expand this, it is actually 1 million, correct? I think so.
mm,
1 million or 1 lakh. Okay. So
mm,
see the error possibility is 1 by 10 power 4. That is the possibility.
mm.
If you increase the accuracy, right? So then it still further increase. So this adaptive
It
meshing,
will it will take the more time to simulate.
exactly, exactly. So what it does is, see, to reach that accuracy, it will keep on refining that meshing basically to reach that accuracy. So before, if it not reaching the accuracy, it will keep on refining. So what it does is initially it will try with, for example, like this mesh. Then it will just, to start doing a small, finer mesh, basically. Smaller, finer mesh. Then calculate this. So that's how,
Sir,
it will
sir,
just, yeah.
So I normally used to do that without adaptive mesh and without
Yes.
port mode only.
Yeah,
So
you can.
just click
Yeah.
suppose I don't click the adaptive tetrahedral mesh and I don't click the calculate port mode only and then start. So,
Okay.
so is this the correct way to do that or
The thing is, see,
is
the
it
thing
wrong?
is, see, if you tick this one, it will just modes, whatever modes you are selecting here, right? That mode will be calculated and it's fine. But if you next, no, initially you want to see the results, right? How this is behaving. Just to do the initial simulation, then you can go for this adaptive for the further refinement. That's it.
Yes, sir. When I don't click calculate mode port mode only and also adaptive tetrahedral mesh. मतलब,
I think,
uh,
you will not see much changes.
मतलब,
Maybe just
I never click port mode and adaptive mesh. Just click start.
okay, okay, okay. I think maybe see if there are two
मतलब,
ways to look. One is you can
this
try
some
both the
technical
things.
question.
Yeah, yeah. Maybe I see the thing is, see, calculate port modes only means, see, it will just the modes associated with this port it will calculate, and then you modes means what? So ultimately you are going to calculate S11, S22, S parameters only, right? So I think I think long back I done. I don't remember now. So you can check and let me know. Okay, if you are
Sir,
getting
sir,
different. Yeah.
sir, just give me 2 minutes. So I'm start simulation. So one more question is in my mind. Just this is the rough. This is
Okay.
the final. But after simulation, there's
Hmm.
some Z-max, Z-min, so many
Yeah.
so
Yes,
many
yes.
results.
It will come. It will come.
So
It will come.
uh,
Definitely.
just give me two. Mm, it takes time. So I'm doing it from my laptop. That's why it didn't take time. But
Hmm.
43%.
You will get something like this. Z max of
Uh,
one,
Z-max,
one.
Z-max one, Z-max
Yeah,
one,
right.
Z-min one. So what does it define? So how do we define the S1 and S2 to an
This
S2
is the
one two?
S11. This is S11 of mode one. Okay.
Okay.
Okay. Which means, see, you have two modes, right? One is E plane, another one is H plane. I mean, see, you can say in other words, you can get, horizontal polarization and vertical polarization, like that you can consider. Okay. This is mode one. This is mode two. Okay. You consider that.
Mm,
For mode one,
okay.
what is my S11? So one means max and two means min. You just map that one. So
So 1 min.
max, one means max. Two,
So
see, for example, like this. Okay, z max of z min of one, z min
mm,
of one, like this. Okay, so
mm,
this
mm.
corresponds to cross polarization basically. Okay,
Okay,
yes,
this is the
two, yes, two,
cross
one.
polarization.
No, sorry, not
Okay.
cross polarization. It is actually transmission coefficient. This is reflection coefficient. This is transmission coefficient. Okay.
Okay.
This is one, this is two of same mode. Okay.
Suppose if you take a polarizer,
Mhm.
which has the aperture along the y-axis, and
One
then
minute, one minute.
uh,
Actually, 1 minute. Actually, this is another case. You will see the Z max of two. Okay. Here one, here two. This is S11 of actually cross polarization basically. One and two.
okay.
Okay. So one and two means, see, what is the cross polarization between these two? For example, if you are having a patch like this, your cross polarization will be cross polarization means, see, between two modes, see, what is the cross polarization I'm having, that I can find out like this. Okay. If you go here now, just go to that.
So now H parameters is coming already. Uh,
Yeah, you can see here. This is actually a, let's say this is, just go to phase. Mm,
it's calculated,
yeah, go on
but
phase.
uh,
1 minute, I will show you. This one is S11 of mode one.
uh,
Okay. Then this one is actually S11 across polarization basically. Okay.
S11.
Yeah, S11 of cross polarization. Between mode 1 and
Okay.
2, what is the coupling between mode 1 and 2? Which means cross polarization basically. So this is the see, this is the unit cell. You are exciting this wave as well as this wave. What is the coupling between these two? That is what it is showing here. Okay.
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 So if you want to take the reflection coefficient and transmission coefficient, now which two
Uh,
parameters and I should take?
I will tell you that this is the reflection coefficient of mode 1. Okay. This is
Okay.
reflection coefficient coupling, or we can say mutual
Uh,
coupling. Okay. Or we can say coupling between the modes. Okay. Then this is S21 basically. S12, I can actually. This is 1. You assume max as 1 and min as 2. S12,
Minus
2.
yes. Okay.
Okay. Then you can see here
So,
this is
so,
max min. Hmm.
just give me one time, 1 minute. I am writing. Just 1 minute. You are saying that max means one
Yes.
and
Min
mean
means
means
2.
two.
2. Yes.
Okay.
Bracket, no, there is a mode. If it is same mode,
Okay.
1 will be there. Okay. Different mode means it is a coupling or mutual coupling or cross polarization, like that you can
Uh,
coin the name.
uh, then just define that. The first one is that one
Yeah.
मतलब reflection
Co-polarization.
mode of
Co-polarization, basically.
is Z max one and Z max one. This is
Yeah,
the
it's
reflection mode.
S11. S11 reflection coefficient of co-polarization. Okay.
Reflection
Coefficient of
coefficient
co-polarization.
of
Co-polarization.
co-polarization. That means what that is different co-polarization.
This means, see, you can see here that you are having 1 and 2. Two polarization, right? Right?
Hmm.
So only you are calculating for this polarization,
Hmm.
not for this. The next item is Z